We're going to spend some time talking this afternoon about building robust systems on top of Google Compute Engine. My name is Mark Cohen. I'm a developer programs engineer at Google, and I'm joined by...
I'm Joe Bita. I'm the lead engineer for Compute Engine.
So we'll hope to give you some good ideas, things to think about, techniques, and approaches to building reliable systems. This is a quick overview of what we're going to talk about. We'll just a quick review of background. I'm assuming most of you have probably heard about Google Compute Engine and know about it, so we'll just give a real quick overview. We'll talk a little bit about why you should care about this subject, what sorts of bad things can happen when you build these large, complex systems. We'll review a bunch of power tools. These are unique capabilities and techniques that we believe really bring some value to the table when you're building these sorts of distributed systems. And then we'll review a prototype application. So a little bit of background. So this is a photograph of Google's Council Bluffs, Iowa data center. This comes from a very informative website, google.com/datacenter. So it's a great resource if you're interested in learning more about the data centers. But the quote here is from an article Stephen Levy wrote for Wired magazine last year. And it kind of speaks to the enormous scale and the, just the incredible magnitude of these data centers. And I like this as a way of thinking about Google Compute Engine, because at its core, what Google Compute Engine is about is getting you into that room, giving you access to some of the world's most advanced computing resources. So a quick run through of kind of a description of what Compute Engine is. Before I launch into this, how many people have already heard about Compute Engine and kind of know what it is? Okay, cool. And how many people have actually used Google Compute Engine? Okay, that's awesome. It's an infrastructure as a service product, and for most people that immediately connotes virtual machines, Linux boxes, things like that, and that's certainly the heart of the offer. But we like to think of it as kind of a very comprehensive package of capabilities. So in addition to the virtual machines, you get some very advanced networking capabilities. You kind of get a private network with a built-in DNS server. A lot of built-in security capabilities like automatically encrypted hard drive and things of that nature. And an array of pretty advanced storage capabilities, which we're going to kind of review shortly. But kind of at a broader level, it's all kind of built with Google's fingerprint. So all of the experience, knowledge, engineering insight, and operational management type know-how that's gone into building out all of the services that Google provides, you know, serving billions of queries a day all around the world. All of that's kind of gone into Google Compute Engine, both in terms of technology and kind of, you know, the design level and also the technology that we're building on top of. So we're really taking advantage of a lot of that history here. As well, it's part of a broader platform of capabilities we call Google Compute Engine. So as you'll see, it enables you to work really well and easily with other aspects of the platform. So I've been giving talks about Google Compute Engine for a while, and at the end of the talk, I often see this expression. And frankly, it's been frustrating because my answer is always very measured and complex. And I'm really, really happy. I may be one of the happiest people here to be able to answer this question more simply than I ever have before. So the answer is yes. If you would like to try this, it's available. We announced Wednesday. It's available for anyone who'd like to sign up and try it, and I'd strongly encourage you to do so. So it's really important to sort of to switch gears a little bit to building complex systems and what sorts of problems we might have and what sort of things can go wrong. Anything can go wrong and everything can go wrong. And I think it's really important to realize that, you know, your hardware is never going to be perfect, your software is never going to be perfect, and your processes are never going to be perfect. So there's kind of a mindset shift that I think is a little bit subtle but really important, which is instead of focusing on building perfect things and writing perfect code, it's also really important to build and design systems that tolerate and deal well with failures, because they're certainly going to happen. And that's a big part of Google's legacy, the whole concept of MapReduce and these huge data centers that I've been talking about. The kind of core principle there is deploying huge numbers of inexpensive computing devices and dealing gracefully with the fact that in that sort of volume, bad things are going to happen and are, in fact, happening all the time. So to be a little bit more specific, whoops, didn't mean to reveal that. I think you guys already saw it. I was going to ask the audience if you had any idea what the single most common factor is in outages and failures. You guys already saw it, I think, right? So it's the human error. It's making mistakes with configuration, procedures, or just accidental operation snafu. And so that's one sort of big factor, one big type of failure that you'll encounter. Then, of course, there's software errors like resource exhaustion, logic bugs. Bad recovery code is kind of a fairly interesting scenario because it's the situation where you've written code specifically to deal with problems. By its very nature, that sort of code doesn't typically get exercised very often and often is not tested thoroughly. And so what you can have there is a situation where the code that's dealing with a problem makes the problem even worse if it's not behaving properly. Of course, we have scheduled maintenance events and unexpected, unplanned maintenance outages, or not maintenance outages, but simple outages. And then there's a wide range of security failures that we can have. So there's a lot of things that can go wrong. And there's really three dimensions to this problem of dealing with these sort of outages. There's the infrastructure layer, there's the application layer, which you guys are responsible for, and then there's the process layer, or the people layer. And we're going to focus today on the infrastructure and the application. We're going to talk about the infrastructure that we provide and share some tips about how you can take advantage of those capabilities. But I do want to spend a few minutes on the human and the process element because I think that's a really important aspect of it as well. This quote captures a lot of what I've been thinking about in this space. And if you get a chance to check out this article, How Complex Systems Fail, I highly recommend it. It's by Richard Cook. It's about a 4-page article. It's hot linked off of these slides, which I'll release after the talk. But anyway, it's a very nice taxonomy of how complex systems fail. And one of the points in this document is recognizing hazard and successfully operating inside tolerable performance boundaries requires intimate contact with failure. So what he's really talking about is practice makes perfect. It's really important to have people who are kind of well-trained in this area and have good monitoring tools and are following processes that are going to help you navigate that fine balance between, it's not a binary, everything's working, everything's not working, but you're trying to make sure that failures, small failures that are happening all the time are well contained. So here are a few process guidelines that we've learned at Google have been very helpful for us with managing our systems effectively. Set reliability goals and track metrics. So make sure to delineate what it is you want to accomplish in the space of your reliable systems, and then have good measurements. If you kind of just state a bunch of goals and then you don't measure it and track how you're doing, then it's not really buying you all that much. Document everything. So any process, what was that? Any problems you're having or issues you're overcoming, it's really important to capture those with postmortems and to make sure you're documenting all of the learnings that you're having, sharing it with your team and so on. Otherwise, you're going to repeat those problems. Automating everything is really important. Anytime you have a manual procedure in your operations processes, so somebody has to go click a button or write a script or run a script, that's an error waiting to happen. So this is kind of an ideal. I mean, it's very hard to do this perfectly, but this should be the goal that we're all striving for. Preparing for maintenance events and outages is really important. At Google, we have regular events where we kind of simulate outages and actually break things fairly intrusively. And it's a great way to not only prepare for, but also to test outages and events. And build a really strong capacity planning model and allocation of your resources in zones so that you have the ability to move things around as and when you need and to adapt to outages on the fly. So that's by way of background. I'm going to turn it over to Joe now to talk about some of the power tools.
Thanks, Mark. So I'm going to cover a little bit of the unique capabilities of Compute Engine and how you can use those to solve some problems in this space, but also some things that exist outside of Compute Engine proper and how you can go ahead and use those. To start with, you got to know your storage. So much of reliability comes down to making sure that your data is there. It's frequently the bottleneck that you're going to hit. And so I want to review some of the storage options with Compute Engine and with the cloud platform. So to start with, starting at the sort of least reliable level, we have Scratch Disk. This is a block device attached to a virtual machine. It lives and dies with that virtual machine. It's cheap and cheerful, but it's also not very durable. And one of the things that you should be aware of is that it's also prone, to correlated failures. So you don't know that you won't see a lot of Scratch disks dying at the same time. So something to keep in mind as you're building your processes. So things like good backups, even if you're using replication, is a good idea. Next is our persistent disk offering. This is replicated off of the local machine over the network, and it's very flexible, and we've built it for fast, consistent performance. I'm going to go into a little bit more detail in the next slide here. So the next is cloud storage. So this is the first thing that actually goes outside of the zone that the virtual machines are running in. And this is blob storage, and it's really a Swiss Army knife when building your application. It's great for getting information in and out of the cloud. It's great for storing things for backups. It's great also for serving. So it can play all those different roles, and it's really a great tool in the toolbox. Next are hosted databases. And so with Google, we have Google Cloud SQL, and we have the newly announced Cloud Data Store, which is the App Engine data store built on top of Bigtable, exposed as an API to anybody who wants to use it. And we use the data store and the technology underlying the data store all over the place inside of Google. And so the best thing to do is let it be somebody else's problem to worry about reliability and to hold the pager. And so finally, you can bring your own data store. I mean, building on top of these tools, you can run something like Cassandra, you can run Mongo, you can run whatever you're comfortable with and whatever solution actually fits your needs. Obviously, it's going to be a little bit more complicated the deeper you get, but your freedom's there. So just focusing in a little bit on persistent disk. It's really a sweet spot in terms of durability, flexibility, and consistency. That's what we really built it for. One of the interesting things, capabilities here is the ability to take snapshots. This is great for backups. There was a talk earlier at I/O, and you can watch the video that goes deep into this system and some of the best practices on how to use it. I encourage you to take a look at that. It's also a very useful thing to move data between different zones and different regions. So if you take a snapshot in Compute Engine of a persistent disk, that snapshot is available globally. And so it really starts to approach a disaster recovery, or at least the piece of a disaster recovery plan. And so you can use this for anything that you would use a disk for: database storage, fast boot, static data that you want to share widely, and for being able to move data between different zones and different regions. So tooling should be used to automate every step. So Adrian's actually here in the audience. He's the cloud architect for Netflix. Is that your right title? Yeah, okay. and I was talking to him last night, and he said automate all the everythings, which is pretty much what it comes down to. So here's some building blocks that we can use to automate your deployments in Compute Engine. So the first thing I want to talk about is instant metadata. There are other clouds out there that provide a way to pass a blob into your virtual machine. We've kind of taken it to the next step and added a few more features there. And it's really a pretty simple feature, but it's very powerful also. The idea is that from the API, you can specify some simple key value pairs. And those key value pairs are then made available inside the VM at a very early stage of the boot cycle. And so you can then use this to pass in all sorts of information that can configure your system and make your systems be more reactive. And you can set it both on an instance-by-instance basis, or you can set it across your entire project. And so this is what we use to distribute, say, SSH keys into the virtual machine. And so let me give you some quick example here. So this is using the gcutil command line tool. Obviously, you can do all of this stuff with the API also. But here I'm passing in two metadata values. One of them is a role with the value of master. And then the other one is a configuration file coming from a text file. And then once I boot up my virtual machine, with that information. I can SSH into it. And then with a simple curl command to a local metadata server that's available only to that virtual machine. So it's a private metadata server for that virtual machine. I can then go ahead and retrieve these key value pairs. So this is a really critical building block for building automated self-configuring systems. So building on top of that, we have simple startup scripts. So this is sort of the next level here. And so this is kind of like RC local if you're familiar with traditional Unix init processes. And you can use this to install packages, download things from Google Storage using our service account feature to do so securely, or bootstrap other management systems. So if you're using something like Puppet or Chef, this can be a great way to get those things installed and working. So here's a quick example of what this is. This is on a CentOS machine, it will install Node. And so the first 4 lines there are providing access to an extended repository, installing Node, and then the next 3 lines are downloading, getting the specific role that this thing should be running, downloading the startup script or the program from cloud storage, and then running that. And so with a few lines of code, you can make this, turn something from being something that you have to SSH into and push configuration for, to something that can actually draw and automatically run what it needs to run. And you can see how you can just simply pass this in as a metadata value for startup script, and our stock images know how to check for that metadata value and start running the script for you at boot. And then the log gets written to var log Google, so you can debug it when things go wrong. And then on top of that, how do you manage images? Images can be a real problem. And so this is like a quick pattern I'd like to show you of creating a script that can be used both for customizing a system at runtime, initializing something for creating an image, or initializing a persistent disk that you're booting off of. And so it's an easy way to mark. This was a leftover from my Fractal demo that I gave on a previous talk. It's an easy way to mark whether you've done a set of steps so far, and if you have, skip that. Those are generally the time-consuming one-time setup type of things, and then actually run the program that you're looking to run. And so finally, you can do a lot with these set of tools, but it'll only take you so far. And so the next step is sort of this broad category of systems that I've been calling orchestration. You can start with something simple like doing a bunch of what I provided here through App Engine, which is a good way to have a system in the sky managing it for you. But if you want to move past that, there's a whole bunch of systems like Chef and Puppet, or partners, commercial partners, like RightScaler and Scalar, that can really help you sort of take this to the next level. And they all offer a different set of features, but here's a good smattering of the types of things that you can expect once you start taking advantage of higher level systems like that. Now the next thing is that scaling and stability really go hand in hand. If you're building for scale, a lot of times you're also building for stability, and all the problems that only happen once in a while all of a sudden start happening all the time. And so these things really do go hand in hand. And so one of the key things here is, use load balancers. I mean, it seems obvious, load balancers give you scale, but load balancers also give you the ability to route around failures. And so they're really going to be a key part of any architecture that's going to be built for stability. And then finally, plan to actually distribute yourself both across zones and across regions. That's both ensuring against, a meteor hitting or software or hardware failures. And if you do it right, and if you build an advanced enough architecture, you can actually provide lower latencies to the people where they are. And then the last feature I want to talk about is our startup times, our fast startup times at Google. This lets you build more dynamic applications that can start and stop instances. And if you get into the mode of thinking about these instances as being ephemeral workers, as stateless as possible, something that you can manage and that can self-configure, then you're well on your way towards building a much more reliable system. And being able to spin things up and down and sort of build that into the fabric of the application that you're building really encourages you to do the right things along the way. So with that, I want to turn it back over to Mark to give a demo that he's been working on.
Thanks, Joe. So I'd like to review a very simple app that I've written to try to illustrate some of the concepts we've been talking about today. I call it Ping Me. And the idea behind this app is that we're going to serve a web service from a cluster of VMs. We will deploy it on a very simple stack, very lightweight, Node.js, the Express web framework, and WebSockets to have some fun with interactivity. What will happen is the server that you reach will be selected by our load balancing capability with built-in health checking. So to be clear, I'm previewing something that we're in testing mode with right now. So it's not an openly available feature of the product, but it's something that we're actively working on. And I'll give you some information at the end of the talk about how you can find out more about that feature. So the way it'll work is you'll connect to the load balancer, or we'll connect to the load balancer. A random server will be selected among the available resources. And once you have the page drawn, we'll click a button to ping the entire concept. And the idea is that your pings they're not really TCP/IP pings, they're not ICMP layer things, they're kind of application layer pings. We're just sending a little short text message to the selected server via WebSockets, and that server is going to turn around and distribute those pings to all of the client web apps connected to the same server. As well, it's going to distribute those messages to all of the connected servers. So basically, your messages will get shared throughout the entire cluster. And it's going to be built on a very simple self-configuring dynamic shared nothing cluster. And the other interesting thing about it's only 200 lines of code. So this is kind of a trivial app in many ways, but I think it illustrates how much you can do with Google Compute Engine. I think the reason it's so small is a lot of the capabilities you might have to build yourself are built right into the fabric of the product. This is what it looks like in action, and we'll actually run it live in a few minutes, but I want to first take a few minutes to show you some code. So it's built on two files, app.js, a typical Node server app, and index.html, the file that it's serving up when you connect to this app. So we listen on port 80, and we use the Express framework to wrap a few type of GET requests. The first one is just a simple root path. GET request will return index.html. And this health path, it gives us the ability to respond to a health check from the load balancer. This is kind of nice because we can define the semantics of what it means to be healthy at the application layer. So we can just have that blindly return OK, 200 OK, I'm happy, or we can build any sort of application logic we want to fine-tune what it means to be healthy and thereby affect whether we get requests routed to us or not. Whoops. We're going to listen for two types of events on the connected sockets. So this is after we've served up the index.html, the client's going to make a WebSockets call back to the server. And we're also going to get incoming connections from our peers. So the first type of event is a browser ping. That's when someone presses the button to send us a message. And what we're going to do there is turn around and forward that to all the connected browsers and all the peers. And so right away, that raises the specter of things traveling around through loops in a directed graph, and we don't want that. So you'll notice that the forwarded ping event handler, i.e. incoming pings that come from peers in the cluster, will only be distributed to the browsers, not to any other peers. So that's how we avoid loops. And of course, that implies that all of the clusters are strongly connected in a mesh. And we've got a bit of logic here to make sure that that happens, and it happens automatically and dynamically. And here's the index.html that gets served up. So here's the ping button, the all-important ping button. And we have two divs to hold the display of the servers and the incoming pings, and that's going to kind of be a real-time stream of the pings. The connect function is defined here and called at the bottom. And that is going to do the WebSockets connection. So I'm using the socket.io library. And here are two event handlers for on-ping. That's where a message comes in to us from the server we're connected to. And all we want to do is prepend that to the pings div. And that way, we'll sort of put it at the top of the list. And so everything's going to kind of stream downward, or stream upward, I guess. It's kind of like a stack, essentially. The newest stuff will be on top. And if we get and we have this is the action to do when you click the ping button. No. Yeah, I think I messed up the name there, but that's basically just sending a ping to the server. Okay, so this is just a system diagram. The user fetches the index.html, going through the load balancer, gets assigned a web server, and then it can ping and have the pings distributed locally. And then we'll show also a multi-server capability where we fetch the page, we do the ping, we get the local update, and then it also gets forwarded to the peer, and we have remote updates happening. So let's take a look at that now. So this is actually going to fail because I don't have any VMs created. I'm going to start by creating some VMs. So I have a little script here called add, which looks like this. And the gcutil command that you see here is doing all the heavy lifting here. I'm just looping over the input arguments. I'm going to put 0 and 1 in the US Central 1A zone and 2 and 3 in the Central 1B zone. And I'll just create 0, 1, and 2 for now, and we'll add 3 later.
One thing to note here is that that command line looks pretty complex, but that was generated using our console. So when you actually go to launch a VM from the console, you can go ahead and do it right there, or actually capture a command that you can go ahead and script.
Right, thanks. And I wasn't quick enough to show you, but those things that are spinning weren't there a second ago. They immediately came into view and they started up, and you see they're all green. They've actually come up. That's how fast we start VMs. And as Joe said, there's some really nice capabilities built right into this is our new cloud console, and it's a very nice kind of updated web user interface for administering things across the cloud, so you can use this for lots of the cloud products. But we're going to focus specifically on Compute Engine here today. So we now have server 0, 1, and 2, and we have this model, which is the genesis of those servers. I'll try to talk about that a little bit, but I've done a trick similar to what Joe showed you, where I have a model server. I customize it, add packages, do everything I want to get it ready, and then I take a snapshot of the persistent disk. I have a root-mounted persistent disk on that model. I take a snapshot of it, and then I can create persistent disks from that snapshot and start up VMs very fast off of those persistent disks. I can also create a disk on the fly with the VM targeted off of the snapshot. So there are a lot of nice configuration options. I'm not going to go through that in depth, but if you click New Instance, you get prompted for all kinds of interesting ways to create a new instance. So let's go back to instances. And this failed because I didn't have any servers. If I'm lucky, when I click it, it does connect. Okay, so what happened was it served me a connection through that. So the 161 is other people may be connecting. The 161 is the load balancer, and it connected me through to server 0. So let's clone that window and pull it out of the Chrome frame and take a look at some of the other servers. So I can actually click on server 1, and that kind of reroutes my WebSocket connection over to server 1. And as you can see, if I click ping here, it shows up on my server. It's showing up on anybody who's already connected. You guys are fast. I didn't say anything about the address, and it's like, bam, you guys are in. And then if I ping here as well, you can see it sends it. So what's happening is these pings are getting distributed locally and throughout the network, which is kind of cool. Now let's try, you guys are going to try to DOS me here. So let's try something interesting. Let's add a VM. And while we're waiting for that to happen, let's take a look at the Cloud Console. There it is, it's already starting. And I'll show you the disks that I have. I have one disk for each server here. You can see the zones, so the disks are zone affiliated, and then I have my master snapshot. So if I wanted to create something with the characteristics of this instance, there's 2 links down here that I want to call your attention to. The first one is REST, and so this is the JSON equivalent of how you would specify this. And technically, I'm not saying this correctly. This is the JSON response from a get instance call. If I was actually going to, a better way to show this would be to say, let's create a new instance. And I would give some characteristics, select a bunch of stuff. And then down at the bottom, somewhere, there it is, equivalent REST or command line. I can click command line and I get the GCUtil equivalent of that creation, and it'll adjust to reflect all the specifications I give. And then the rest is, as I said earlier, it's the JSON equivalent of the RESTful API to do that instance add. This is really super duper powerful. I'm really excited about this, and that's why I'm spending a lot of time on it. It's like you can go through the UI and use it as a very simple point and click mechanism to specify what you want to do. And then you have immediate access to things that tell you how to do the equivalent of what you've just done interactively via code and via command line. I think this is totally awesome, and I'm really, really proud of what the engineering team has done to make that available to you guys. Let's check on the instance. It's now up and running. And so now you see we have server 0, 1, 2, and 3. And you may note that I didn't refresh anything. So these web pages just magically from WebSockets found out, oh, there's a new server in the group, and we're getting stuff from it. And as you can see, we're still able to send, actually, there we go. You guys are hitting this so hard that I couldn't see the ping I just sent. But the other thing I want to show you very quickly is if I refresh that whole page, I end up on server 1. So it's just showing you the load balancer is kind of doing its thing. Now, one last thing I want to show is I'm going to kill. Actually, let me do the delete using the console. So I'm going to select server 3. I'll scroll down there. And one thing to note here, this robust IO13, that's a tag. And that gives us the ability to refer collectively to a group of servers via the tag, which is very convenient when you're administering networking capabilities. For example, you could have a firewall rule that says, let this traffic in for any VM with that particular tag. That's a nice capability. Won't go too far into that right now. But I'm going to delete this instance. And the Cloud Console will show it spinning. And let's see if there's anything else I wanted to show you on the Cloud Console. I am going a little late on time, so let me see what I have coming up here. Okay. Still deleting, so let's come back to that. Just in the name of time here, let's keep marching ahead. So I've shown you kind of a multi-server configuration. We talked about the single server. Let me enlarge that for you guys. And let's look at the multi-server. We've talked about that. If you're a real-world application, of course, you never have just a pure web server. You have some sort of back-end data store. And it's really important to have that capability also be resilient and fault-tolerant and nicely scalable. And so a typical approach here is to choose one of many popular open source or commercial database servers. There are a lot of great choices out there, and deploy them in this sort of a fashion. If you get big enough, you probably want some sort of a load balancing capability, an internal load balancing capability between your front ends and your back ends. This is widely known practice standard throughout the industry. But there's another option which I wanted to talk about, which is to replace the whole back-end tier with a managed service. And Joe talked earlier about some of the capabilities we're either have been offering or have recently announced, like Google Cloud Storage, the data store, Cloud Data Store, and Cloud SQL. And the beauty of this approach is that you tap into, it's kind of like what I was talking earlier about taking advantage of Google's DNA and everything that's gone into our designs. You get to tap into a ton of expertise and technology that makes it super easy to access services that are just super scalable from day one, super high availability, extremely replicated, geo-replicated, all that good stuff. And you don't have to worry about managing servers and processes anymore. So that's kind of it. Let me jump back to the demo and see if it actually worked. Okay, so server 4 went away. Again, I didn't refresh the app. I didn't do anything. Let's see if this guy's, yep. So you're probably wondering, did that really work? Like, it would be nice to have seen that go away. But anyway, you'll have to trust me on that. But these guys are talking to each other. They're exchanging information dynamically. They're using a lot of the capabilities that Joe talked about earlier, using metadata. The color that they use is configured as part of their metadata. So when I create a new server, I can assign it a color in its instance-specific metadata, and it'll do that or change it. So a lot of nice capabilities here, along with the load balancing and the snapshots and all that good stuff. So try to finish up here because I want to leave a little bit of time for questions. The last thing I wanted to mention is just a few simple takeaways that I want to leave you with. Whoops. So it's kind of a summary of what we felt were the key points we were sharing today. One is that reliable systems are really a combination of infrastructure, that's what we're trying to give you and do a great job of. Design, that's your apps and all the logic and business processes that you guys work with every day, and then people, and we talked about that earlier, some of the good people processes that you need to think about when you're building reliable systems. It's super important to manage your config, your deployment, and your scaling as if it were code, as if it were the critical artifact, one of the critical artifacts of your business, because it really is. So the app I've shown you is kind of a toy, and I think it shows a fairly cool amount of stuff that you can do on your own. But as Joe mentioned earlier, there are a lot of great options out there to do more sophisticated and declarative type processes around that. Fast starting servers are awesome, they rock. They help you scale better, they help with your availability, and we're looking forward to making resources available even faster in the future. Power tools to build self-configuring, shared little stateless servers along the lines of what Joe showed you earlier, really important. Take advantage of managed services, as I just mentioned. There's a real value, I think, in terms of not having to reinvent the wheel there. And plan for all the different types of outages that are possible. I didn't actually show this, I'd meant to, but I just killed one server. I'm not going to take any more time on it, but if I had killed 2 and 3, which were the 2 in the one zone, you would have seen that the load balancer was still happy and all the service requests would have just gone to one zone. So it perfectly would have tolerated losing an entire zone in that model. And finally, stay tuned for more awesomeness. We've mentioned the load balancing. We haven't mentioned system monitoring, but that's another thing that we're working on actively. And we're really excited about continuing to add great value to this product. And we have something called the Early Access Program that you can link to here. It's a way to sign up to get access to some of these capabilities. And finally, your homework is to take some of these guidelines and build super awesome systems. We're really excited to see what you guys are going to do with Google Compute Engine and the Google Cloud Platform in general. Here's a few places you can learn some more about the Compute Engine and Cloud Platform. I'm going to make these slides available via that link at the top. They're not there right now. If you go there right now, it won't work. Within about an hour from the end of this talk, I'll upload the slides, and you'll be able to find them at bit.ly robust-io13. And with that, I would like to thank you guys for coming today, and thank you, Joe. So we'll take... And I think we have 1 minute and 8 seconds for questions. I apologize for that, but we'll stay here and talk as long as you guys would like. Any questions? So the question was, to manage infrastructure and code, what kind of tools do we use? So we have a bunch of internal, as you would guess, elaborate tools and processes at Google that we use to manage our code and our development cycles and deployments and all that stuff. I don't think we're allowed to go in too much depth on that, but I was really talking about some of the, or Joe was talking about some of the open source options like Chef and Puppet, as well as the commercial scaler and RightScale.
We're always looking at new opportunities to take some of our internal technology and learnings and externalize them. Just have to prioritize what we think will provide the most value and work our way down the list. So eventually, hopefully, we'll find a way to get that stuff out to everybody.
Other questions? We've either put you guys to sleep or we've answered. Oh, here's a question.
Do you mind using the mic? Thank you.
The scheduled maintenance that Google undertakes regularly, just if you could speak to patterns for designing robust systems around that?
Around the scheduled maintenance?
Yeah.
Well, it's essentially practicing for failure. I think you get some warning. It's a way for you to test your procedures and your systems. I think because we do have those types of maintenances internally also, it leads us to build systems that you got to be honest with yourself and you can't cheat. You can't get away with it.
Were you referring to the specific schedule that Google has for?
Yeah, that's right.
So the rule of thumb is the zones currently go into a maintenance window roughly twice a year. And they go into that state for up to 2 weeks. So that's
if you had a live service at that point, you would move it across.
right. And so we have some capabilities in that area to help, like the gcutil command that I was using to show how to create instances. Yeah. Also has a capability for migrating virtual machines with attached persistent disks from one zone to another. But we're continuing to work on that area to make the process simpler and less impactful on people. But we also kind of feel like if you design your system so that it tolerates a scheduled outage, then you're kind of doing the right thing for any eventuality.
Okay, thank you.
I think we're all done. Oh, one more.
Hi, I'm Adi.
Hi.
Right now, there is a limitation in Google App Engine, 60 seconds for processing a request. There's an App Engine.
So the question was about the 60-second limit on
In
Google.
App Engine, but the question actually is a limitation still continuing when you introduce the load balancer in Compute Engine?
So does the 60-second timeout, is that manifested in Google Compute Engine?
No, in App Engine. So in Google Compute Engine, if you introduce a load balancer, so will there, is that still that would be a 60-second limitation? Or
The type of load balancer that we're demoing here is a low enough level that it just forwards TCP connections, and so it's up to you to implement whatever you want on top of that. So you can use it for things beyond just HTTP also.
okay.
All right.
So we'll be around you'll be here for a little bit. We'll hang out for a little while if anybody wants to come down and talk. But thank you guys very much. Hope you had a great conference and have a good time.